Hello everyone and welcome. In this video I'm going to talk about invariants. Now invariants are a mathematical concept, but they are really important if you want to learn algorithms or you want to learn how to solve problems efficiently, because that's what you're doing when you're programming, right? You're constantly solving mathematical problems by telling the computer what to do through code, right? So invariant is basically something that doesn't change. And this concept is particularly useful when you have a certain initial configuration and you have some kind of operation that you can perform or multiple operations that you can perform, and you want to know whether it is possible for you to reach a certain end configuration. Now, I know this is a bit abstract, so let me give you an example. Imagine that you have two rocks in your hand and you can either receive 2 rocks or you can receive 4 rocks. Okay, these are the possible operations, and this is the initial configuration. And now my question to you is, can you perform a certain sequence of moves that allows you to end up with 73 rocks in your hand? Well, you don't have to think too much about this to realize that the answer is no, right? Because 2 is an even number, so you start with an even number of rocks, and then you can either add 2, which is also even, or you can add 4, which is also even. And so you're always going to have an even number of rocks in your hand. And so it is impossible for you to reach a configuration where you have 73 rocks in your hand because that number is odd. And so our invariant is in this case is the parity of the number of rocks, right? That doesn't change. You always have an even number of rocks in your hand independently on the operations you perform. Okay, so now that you know what an invariant is, let's try to solve a slightly harder problem. So imagine that you have a set of stairs that has 6 steps, and each step has a frog on top. Now, I don't know how to draw a frog, so I'm just going to draw these little circles. Now, each step has a height of 1. So the first frog is going to have a height of 1. The second frog is going to have a height of 2. The third is going to have a height of 3, until the last frog, which is going to have a height of 6. Now, when you move one frog up 1 step, you're obligated to move one frog down 1 step. So, for example, if you want to move this frog to this step, you have to move some other frog to a step that is lower than the previous step. So, for example, this one to this step. So these are the operations that you are allowed to perform. Now, I want to know if there is a possible sequence of moves that allows you to end up with all of the frogs in the same step. So try to think about this a little bit. Well, how do you approach this? Well, you know that the initial sum of all of the frogs is going to be, of the heights of all of the frogs is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is going to be 21. And when you move one frog up, you have to move another one down. So you're going to increase the height of one frog by 1, and you're going to decrease the height of other frog by 1. And so the sum that you're going to end up with is going to be the initial sum plus 1 minus 1. And this is going to be 0. So this is going to equal the initial sum. So you conclude from this that the sum of the heights of all of the frogs, oops, I've erased 1 step, didn't mean to do that. You can conclude from this that the sum of the heights of all of the frogs is going to be constant independently on the operations you perform. And so that's going to be our invariant. The invariant is going to be the sum of all of the heights of all of the frogs, and that's going to be a constant value. Now, if the frogs were all in the same step, you can conclude that the sum of the heights of the frogs would be equal to 6, which is the number of frogs, times k, which would be the number of the steps. So if they were all in step 3, then the sum of the heights of the frogs would be 6 times 3, which is 18. So the possible values that the height can take are 6, if they were all in the first step, 12, second step, 18, third step, and then 24 is going to be the fourth, and then 30, and then 36 is going to be the last step. Now, none of these values is 21, which is the initial sum that we've calculated and that we've concluded that stays constant throughout time, independently on the movement of the frogs. And so, with this way of thinking, we can conclude that it is in fact impossible to perform a sequence of moves that allows you to end up with all of the frogs in the same step. Okay, so those are invariants. Now, what about monovariants? Well, monovariants are properties that can change throughout time, but you know exactly the way that they're going to change. So imagine that you're playing a card game with a friend of yours, and you each start with 50 coins in the beginning. Now, there is an organizer of the game, and each round you're going to have to pay a coin each to the organizer. So each round, the organizer is going to receive 2 coins, one from each of you. Now, the game consists in the organizer giving you and your friend a card, and then the one that ends up having the highest card is going to win the round, and the loser is going to have to pay 2 coins to the winner. Now, my question is it possible for this game to run for an indefinite amount of time? So, is it possible for this game to continue until infinity? Well, no, right? Because every time there is a new round, you're going to have to pay a coin to the organizer, and so is your friend. So you start with a total of 100 coins, and then you're going to have 98 coins, and then 96, and then 94, and etc. So you can conclude that each round, the sum of the coins that you and your friend have, so the sum of the coins that are on the table that you're allowed to play with, is going to decrease by 2 because that's the amount of coins you're going to give to the organizer. And so you can conclude that there's going to come a time where you don't have any more coins to spend. So you can't perform any more rounds, and you conclude that the game can't run infinitely. So that is a monovariant. The sum of the coins isn't constant, but you know that it decreases by 2 coins each round. So that's going to be your monovariant. And that's it for this video. I hope it was easy to understand. If you have any questions, don't hesitate to ask. Try to solve some problems using these concepts, and I'll see you in the next video.